All right, today's Tuesday, March 5th, 2019. This is the substitute work that I've left for you guys. We're just going to go over the answers really quickly. So the first one here, all right, is identifying the independent and dependent variables. So as we go through this, right, we just want to read each situation. A parent bases a child's allowance on the number of chores completed by the child. So since the allowance is based on the number of chores is the independent variable. Okay, so this is the number of chores is our independent variable, and our dependent variable is the child's allowance. So allowance, that's our dependent variable. Okay, sure. All right. Next up, we have the participation grade in class is calculated in part by the student's attendance. So the attendance contributes to the participation grade. So that tells us that the attendance, okay, is going to influence the ending participation grade. So that's our dependent variable. Next up, trees grow from sunlight and water. So we have two things happening here. The trees get sunlight and water, and then they grow. So whether or not they grow is dependent on the sunlight and the water. So the amount of sunlight and water is the independent variable, and the tree growth is our dependent variable. Okay? All right, next up, let's see. We got give the definition of the term. Okay? So we talked about in class the domain is the set of all independent variables, values, x. Okay, that's good for the domain. Right? I'm just looking for the domain is the x, right? The domain is the x. And then for the range, we could say that the range is the same thing. It's just the set of all dependent values, y. Okay? Easy peasy. Next up, here we have a situation. Online Photo Lab charges 25 cents per print to make a color print from a digital file. This is true if you go to Walgreens or Rite Aid or whatever, they can print out your photos. Okay, during a special promotion, customers receive 50 cents discount if 12 or more prints are made. So we have here, which is true, the cost C is a function of the number N of prints made, or the number of prints made is a function of the cost C. Well, in this situation, the cost is determined, let me underline this, the cost is determined by the number of prints, right? When you go to the register, they say, how many prints did you get made? And then they charge you whatever it is. So the true statement here is this first one, okay? The cost C is a function of the number N prints made, right? That is the true statement, okay? Question B, what is the cost of making 20 color prints from digital files? So here what we do for B, right, we would say, well, each print is going to cost me 25 cents, and I'm going to make 20 of them. And then since I'm making over 12, I'm going to subtract 50 cents. And that's the math that you would do. So if we go over to our calculator, we could put that in. So 0.25 times 20, take away 0.5. $4.50. Would you pay $4.50 to have 20 of your favorite photos printed out? So $4.50. Question you can ask yourself. All right, next up. So here we have this function, okay, and we want to label the different parts of it. What is what? So we have y equals fx, okay, and what is what? So the function or the function name. Let's give this a different color. So the function is f. The value of the function is going to be f of x, right? F of x means what it's equal to. So here, that's what it is. The dependent variable we have would be, it's not this. I'm going to do some fancy stuff. The dependent variable is y, and the independent variable is x. Okay? Next up, 8. Okay, here we have some more work. Okay, so let G, so G is defined by this function. We square the T and we subtract 5. So if we're doing G of 7, so G of 7, so for A, we're going to do G of 7. So for G of 7, that means we're going to take our T, which is now negative 7. We're going to take negative 7, and we're going to square it, and then we're going to subtract the 5. That's it. Boom. Okay, so we could say negative 7 squared is 49, because that's negative 7 times negative 7. How are we doing on time? 49 minus 5, and 49 take away 5, take away 5 is 44. Okay? Part B, find the value, okay, t, such that g of t equals 12. So we're thinking when is 12 equal to t squared minus 5? And you guys can do this, right? Okay? G of t, instead of this right here, this is now going to become 12, right? We can do this, right? This is a simple equation y'all can solve, right? So you would add 5 to one side, add 5 to the other side. Boom, that goes away. 12 plus 5 is, high intensity math here, 17, equal t squared. T squared, that's a 2. Okay, t squared, that looks like an ugly 2. Let's make that nicer. T squared. Alright, so how do we undo a square? You take the square root. Okay, so you take the square root. Alright, so we could have here that actually t is equal to the square root of 17. And when you take the square root of something, it's worth it to review this. When you take the square root of something, it's actually the positive and negative version of that. So negative 4.1, let's just do 1, 2, 1, 2. Because if you took this equation and you plugged in 4.12 squared minus 5, right, you get almost 12. And if you took the opposite of that, negative 4.12 squared minus 5, you plug in 12, you also get the same thing. So there's actually 2 solutions here. All right, that's A, that's B. Boom, check. Okay, find the domain of G and the range. So let's go ahead, let's go to our calculator and let's graph this. So let's just put this in our calculator and graph it. So we have a function. So it has t here. We're just going to use x squared minus 5. And we're going to, x squared minus 5. And we're going to graph it. So let's take a look at the graph, and hopefully it's something nice and clean and neat to look at. Oh, that looks pretty good to me. All right, so when we look at this graph, all right, what can we see, right? So we notice that the graph kind of has an arrow on one side and an arrow on the other side. So we talked about the arrow left and the arrow right. The domain we use is infinity, right? So negative infinity, less than x, less than infinity. And then the range is how far down, what's the lower bound and what's the upper bound. Now we notice that the graph kind of stops down here and goes all the way up. And we count, it goes down 1, 2, 3, 4, 5. So the lower bound is negative 5 and the upper bound is positive infinity. So our range would be from negative 5, it's equal to negative 5, less than or equal to y, less than infinity. Okay, and then I really want to see what this says down here. Okay, and then so that's what we get there, and then we have evaluate GP of 3. So let's do that. So we'll do that right here. So this means instead of where we see the t, we're going to put in p plus 3. We're going to square it. And then we minus 5. So this is where that box comes into play. Boom, 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 boom. There's a box. All right, we got to figure out what is p plus 3. So we have a p, and a 3, and a p, and a 3. So p times p gives us our p squared, p squared. Okay, we have 3p. 3 times p here is 3p. And then this is 9. So this part right here becomes p squared. Okay, plus, now 3 and 3 together, we add those together, makes 6p plus 9 minus 5. So then we have what, 9? So we have one more step because the 9 and the 5 we can put together, right? So we would have our answer is p squared plus 6p minus 4. That's 9. Okay? 9 minus 5 is 1. And that's our answer. Okay? That's it. All right, 9, consider this. Evaluate HQ of 1. This is actually a real easy problem. Okay, so H of x minus 3, okay, is just going to be square root. Wherever you see that x, you're going to plug, or q, it's q. Okay, you're going to plug in q minus 1 plus 3, and that's just going to be square root q, that's my q plus 2. That's it. Because the minus 1 and 3 make q plus 2. Part B, okay, part B, we have here, I really want to know what this says. Yep, part B says, for what value does this equal to 3? So this is what we got here. Where is that equal to 3? Oh, man, this is all not what I want. This should say a 1 right here. I mean, it's right, but it's, I don't know what it looks. This would be q minus 1. So we plug in q minus 1. There's nothing in front of these parentheses, so you just, this is the same as q. Minus 1 plus 3. Minus 1 and 3 makes 2. So this question here says, when is this equal to 3? So this says, when is the square root of q plus 2 equal to 3? And we just have to solve it by kind of undoing what we got going on here. So we have to undo our square root. So how do you do that? You square it, and you square this side. So whatever you do to one side, you have to do the other. That crosses out, so you have q plus 2 equals 9. Boom, 3 squared is 9. To solve it out, you would subtract 2, okay, and you end up with q equal 7. Okay, q is equal to 7. That's your answer. All right, so that's what we get for that, 9. Okay, 10, 11, 12, somebody kind of wrote in this, but this is where we use the vertical line test. Okay, the vertical line test, and that just says, okay, if a line passes through the function only once, it is. Now we'll say if a line passes through the function more than once, it is not a function. And sometimes if it's not a function, passes through, we call it, instead of a function, we call it a relation. A relation. And let's make this look nicer. There we go. Okay. It is not a function. Boom. That's important stuff. Bold. All right, so if we take our graphs right here, let's just draw some test lines, and vertical lines go up and down, like your vertebrae in your body. So here we go. There's a line. That's not. That could be more. That pink color should be like. Let's see red. Okay. So see it crosses through 1, 2, 3 times. Not a function. Not. Okay. This one right here. Okay, we take the same line. All right, anytime we, that is a big line. All right, so we take a line, we cross it through, and only cross it through one time. No matter where I draw this line, it's only going to cross through once. That tells us that this is a function, okay? And then our last one, right here, wherever this crosses through, it only crosses through twice. Boom, 1, 2, not a function. Cross through twice, boom, not a function, right? So same thing as this. Okay, this is not a function. Make sure you understand that. I know you know it and you've done it before. And make sure you kind of get that. All right, that's the end of our review. All right, tomorrow we're going to have a test. Okay? All right.